Hi! There are many videos on how you can make a double-sided PCB like this at home, so I decided to show you how to do it. I used the ink transfer method in the past, but I later found out that the photosensitive method is much less work and it is more reliable. First, I print a PCB template on a transparent film. When I cut the board, I make it a bit larger at first because my cuts with a hacksaw are not particularly straight. So I add 5 extra millimeters on each side of the board and I make it straight after the etching with a grinder. The copper-clad board has a photoresist film applied onto its surface. When we expose the photoresist to ultraviolet light, it undergoes a chemical change that makes it soluble in sodium hydroxide solution. You can buy the solution or make it yourself using a common drain cleaner containing sodium hydroxide. It is important to remove the burrs from cutting, otherwise the glass won't be able to press the template properly, resulting in overexposure of the photoresist. If you want to use this method, you'll have to experiment with different exposure times because it really depends on your setup. For me, it takes like 15 seconds, but I've heard people say it takes up to 7 minutes. It is crucial that the exposure is uniform across the whole board, otherwise you will have underexposed or overexposed areas and you can just throw the board away and start all over again. And here you see how the photoresist dissolves into the solution. For etching, I am using iron-free chloride. When etching the board, don't immerse it into the etchant. Let it float on the surface of the liquid. In this way, the copper falls to the bottom of the container and it is easier to handle. You will also make less of a mess. The whole etching process lasts about 20 minutes. When I make a double-sided PCB, I use 3 holes in corners as marks to position the template for the other side. The process of etching the other side is virtually identical to the etching of the first side. Just be sure to use a new batch of sodium hydroxide solution for the development of the board. The reason for it is that some of the sodium hydroxide was already used up during the development of the first board and now it is contaminated with small particles of dissolved photoresist. This can interfere with the development process and prevent proper etching. When you're done etching, you can pour the etchant back into the original container. After a few etchings, the ferric chloride will get used up and it won't etch anymore. You shouldn't just pour it down the drain because now it contains copper 2 chloride and copper is considered toxic. Just bring it to your local waste collection point and dispose of it safely there. After the etching is finished, I cut the board to its final dimensions, grind it, drill the holes and clean it using steel wool and acetone. I use simple wire for vias that I soldered onto both sides of the board. After soldering the vias, I clean the board using acetone because the flux residues can be corrosive and can degrade your board over time. They are also sticky and attract dust. After cleaning, I apply conformal coating for protecting the board from oxidation and moisture. But the best thing about it is that you can handle the board with no worries of making it dirty. And here you can see the finished board.